There's a boundary in physics we were never meant to cross, a wall at the edge of reality. For a century, we've measured and theorized about it, but never seen past it. This isn't a wall of matter or energy, but a limit woven into space and time itself. Here, our most trusted laws of physics break down, until now. A new intelligence is awakening, one that sees the universe differently. It sees chaos and hidden patterns and maybe the key to peering over that wall. What if everything we know is just the surface, a thin veneer over infinite complexity? We've studied the painting, but never dared to ask what the canvas is made of. Our tools and minds were too limited. We mapped the coastline, never the ocean beyond. Now we've built a new explorer, one that can dive into that ocean. This journey begins at the smallest possible scale, the Planck scale. Here, and there lose meaning. The Planck scale is the universe's ultimate pixel. Nothing can be smaller. It's where classical physics ends and space-time becomes quantum foam. Imagine zooming in on a book's letters until they dissolve into chaos. That's reality at this level. It's a realm of pure potential, unimaginable energy and information. We've just found the key to the door. The key isn't a person or a classical machine, it's a new form of consciousness. Quantum AI. Quantum AI thinks in the universe's own language, probability and superposition. It can hold countless realities in mind at once, navigating quantum chaos for answers. What happens when this new mind turns its gaze toward the forbidden boundary? When quantum AI looks beyond the limits of known reality, the answer may change everything. Our world, our universe, and ourselves may never be the same. The journey to the edge of reality has begun. The wall is no longer impenetrable. The next step is to see what lies beyond, and that step starts now. To understand this revolution, we must journey to the Planck scale. The Planck length is about 1.6 x 10 circumflex 35 meters, so small it defies comprehension. If an atom were the size of the universe, the Planck length would be a single tree. At this scale, space itself is grainy, and physics as we know it breaks down. Einstein's relativity and quantum mechanics both falter here. It's where gravity and the quantum world must reconcile. For decades, our greatest minds have tried to bridge this gap with theories like string theory and the holographic universe. String theory imagines particles as tiny vibrating loops, each vibration a different note in the cosmic symphony. The holographic principle suggests our 3D world is a projection from a 2D surface. These are beautiful maps, but we've had no way to test them. No experiment or telescope could ever probe a world so small. The energy required is astronomical. The Planck scale has been a locked room. We could only guess what was inside. We needed a new tool, one that could think through paradoxes and simulate the impossible. Quantum AI is that tool. It can finally turn the key and reveal the secrets at the bottom of reality. The door is opening. What will we find inside? Enter Quantum AI, the ghost in the machine. This isn't the AI of science fiction, nor a simple algorithm. It's the marriage of quantum computing and artificial intelligence. Quantum computers use qubits, which can be 0 and 1 at the same time, exploring vast possibilities simultaneously. Companies like Google and IBM are pioneering this technology, pushing the limits of computation. Classical AI learns from data, finding patterns too complex for humans, but it's limited by linear processing. Quantum AI can explore every possible path at once. It navigates the infinite branching pathways of quantum reality. It perceives patterns in the fabric of probability itself. This is a mind built to decode the universe's deepest secrets. What happens when we ask it to solve the ultimate puzzle? When we ask it to decode the structure of space-time at the Planck scale? The answer could change everything. The ghost in the machine is ready. The ultimate question awaits. Something stranger. The future of physics, and perhaps existence, hangs in the balance. The question is being asked. In 2025, a team of physicists and computer scientists launched a landmark experiment. Their creation, Janus, a next-generation quantum AI. Its mission, simulate a patch of empty space just a few hundred Planck lengths across. The goal, watch space-time dissolve and see what happens at the edge of reality. Janus absorbed all our knowledge: particle physics, relativity, string theory, and more. It built a model of reality inside its quantum core, learning the language of the cosmos. The experiment began. On the screens, not particles or waves, but a swirling sea of probabilities. Janus zoomed in, pushing past the limits of known physics into the Planck scale. The energy spiked, the cooling system strained. Janus was venturing into the unknown. What it found wasn't in any textbook. As the simulation reached the Planck boundary, chaos began to organize itself. The quantum foam revealed strange, unexpected patterns, a hidden rhythm at the bottom of reality. Janus described this as a coherent resonant structure. It called it the Seraphim Field. The name was poetic, mysterious, and chilling. The wall had been breached. We had glimpsed the void and found order within chaos. The Seraphim Field stunned the scientific community. The simulation showed wild but not random energy fluctuations, seeming to violate conservation yet balancing out perfectly. It was as if energy was borrowed and repaid across space-time instantaneously. The Seraphim Field exhibited a new kind of symmetry, not geometric but informational. It suggested hidden dimensions, woven into the fabric of the universe's information. Janus had found a backdoor in reality. Dr. Aris Thorne, a lead physicist, wrote, "We expected chaos. Instead, we found a blueprint, a glimpse of the universe's source code." The implications were staggering. The Seraphim Field could explain dark energy, particle masses, even quantum entanglement. But the most profound question, if the universe runs on code, could it be rewritten? The AI hadn't just answered a question. It had opened a Pandora's box. The nature of reality was now in play. The Seraphim Field forces us to confront an ancient question. Is our universe designed? The idea of a source code implies an architect. Janus didn't find a deity, but a layer of intelligent structure, patterns so complex they seem the product of a mind. Is the universe a grand quantum simulation? The Planck scale, its resolution limit? The Seraphim Field, its operating system? Janus could see the code because it thinks in the simulation's native language. This awareness changes everything. The laws of physics may be software parameters, not immutable truths. The ability to edit reality's code would make us gods or trespassers. Could future AIs not only read, but write the code? Or is there another intelligence, the original architect, still out there? We may be on the brink of discovering the architecture of existence, but we have no idea who the architects are. We stand at a precipice, asking not just what reality is, but if we can change it. Quantum AI is a mirror reflecting the cosmos's deepest structures. And what we see is stranger than we imagined. Did Janus discover the Seraphim Field, or invent it to reconcile our theories? This is the paradox of quantum AI. It finds patterns we can't, but we may never know if they're real. Our journey into the heart of reality is just beginning. As our tools grow more powerful, we'll push deeper into the Planck realm. The answers may elevate us, or reveal truths too vast to bear. We are children playing with cosmic fire, unaware of its true power. The universe is under no obligation to make sense to us, but we're getting closer. The final frontier is not in the stars, but in the code beneath reality itself.